in this question, we are required to show that there's no point where the tangent to the curve is horizontal. So, I mean, that basically means that we are required to show that there's no point in the curve where dy over dx is equals to 0. So, this means that we have to show that there's no point where dy over dx is equals to 0. And then part B of this question, we are required to find the coordinates of the points where the tangent to the curve is vertical. Where the tangent to the curve is vertical, that implies that where the change in x is equals to 0. So these points are points where change in x is 0. Okay, so let's start with the first part. Of course, for us to show that there's no point where dy over dx equals to 0, we have to find dy over dx. So for part A, to find dy over dx, we have to differentiate this equation implicitly. So just differentiate each term. This is plus. So because this is a product of two functions, well, we have to apply product rule. So that will be x multiplied by d over dx of y plus y d over dx of x, which should be equal to, now the derivative of y squared will be 2y outside, and then inside will be dy over dx, applying chain rule there, and then plus 0. So we end up with x multiplied by dy over dx plus y will be equal to 2y dy over dx. And we can rearrange this so that we have x dy over dx minus 2y dy over dx will be equal to negative y. So x minus 2y multiplied by dy over dx will be equal to negative y, which implies that dy over dx will be equal to negative y over x minus 2y. So that's the gradient function, but we are saying that we want to show that there's no point where the tangent to the curve is horizontal. So this, we want to find the values of x and show that there are no points on this curve where dy over dx is equals to 0. So equate this to 0. And if you equate this to 0, you'll end up with y being equal to 0. I mean, if you just solve that, if you solve this, then y will be equal to 0. Now, if y is equals to 0, we want to check whether there's such a point where y is equals to 0 on this curve. So at y is equals to 0, so at y is equals to 0, if you plug 0 in place of x, you'll end up with, sorry, if you plug 0 in place of y, you'll end up with 0 being equal to 0 plus 4, which doesn't make sense because the left hand side is not equal to the right hand side. So what does this mean? This implies that there's no, that such a point does not exist on this curve. Yeah, so this implies that such a point does not exist on this curve. And that's basically what you're required to show in part A, that there's no point where the tangent to the curve is horizontal. Yeah. So for part B, we are required to Find the coordinates of the points where the tangent to the curve is vertical. Where the tangent to the curve is vertical, we've said that change in x will be equal to 0. And if you look at our d over dx, this is change in x. Yeah, and you're saying that change in x should be equal to 0 where the tangent is vertical. So that means that x minus 2y will be equal to 0, which implies that x will be equal to 2y. Now, to find the corresponding y coordinates, because we want points, x and y. So to find the corresponding y coordinate, we have to plug this into the original equation. So in the original equation, I replace x with 2y. So we shall end up with 2y multiplied by y will be equal to y squared plus 4. So this will be 2y squared will be equal to y squared plus 4, which implies that y squared will be equal to 4, which implies that either y is equal to 2 or y is equal to negative 2 by finding the square root of 4. So we have these two. All right, so when y is equals to 2, yeah, so at y is equals to 2, using this equation here, it implies that x, so when y is equals to 2, x will be equal to 2 multiplied by 2, which will be equal to 4. So the point will be 4, 2. That's the first point. And at y is equal to negative 2, x will be equal to 2 multiplied by negative 2, which will be negative 4. So the point will be negative 4, 2. And these are the points, these are the coordinates of the points where the tangent to the curve is vertical.